let's talk about concurrency. What is concurrency? You can think of it as the ability to do more than one thing at a time. So, for example, when you work on your computer, you may be working on a word processor. Probably you're writing a document. But at the same time, you might have a song playing in the background, or you might also have some files downloading in the background. All of those things are happening at the same time. And so different applications are running on your computer simultaneously. But you can think of even just one application doing many things at the same time. Let's say when you're watching a video on the internet, a lot of things are happening inside one application at the same time. Let's say you are using your browser to watch a video on YouTube. Your browser is reading information off of the internet. At the same time, it is updating the display on your computer. And while all of that is happening, you can also comment on videos. So you can do a lot of these things at the same time. And those are all examples of concurrency. When we think of concurrency in Java, we can think of two basic units of execution. We can think of processes and we can think of threads. A process is a self-contained execution environment. So you can think of one application as a process. If you are running a game, let's say, then that is a process. If you're running a software where you can listen to music, that is another process. Now, each process has its own memory space, and whatever work the process needs to do, it utilizes that memory space to carry out that work. Threads exist within a process. You can think of threads as lightweight processes. Threads are also processes, but they are used to carry out very specific tasks. Each process has at least one thread. So up till now, whenever we created a program in Java, usually we were using the main thread. We've already talked about processes having their own memory space. Threads share the process's resources. For example, threads share the memory space that the process has, or if the process has any open files, then the threads share those as well, depending on what task each thread is carrying out. Now, processes can have multiple threads, and that is how they're able to accomplish multiple tasks at the same time. Usually, the main thread is used to create these new threads. And we will see how the main thread can be used to create other threads that will be used to complete different subtasks. So let's look at a couple of examples so that all of this becomes a bit more clear. Let's say you're playing a multiplayer game. So in that case, the game is the process, and the game will have its own memory space in your system. The main thread of the game will be where the gameplay happens. But there can be many other things happening while you're playing the game. If it is a multiplayer game, then you might be playing it over the internet. And there would be a thread that is managing the network connection. But at the same time, if it is a multiplayer game, then you might be chatting with other players. The chatting feature would probably be handled by a different thread. And so you can play the game as well as chat with your friends at the same time in the game application. At the same time, you might also be recording your game. And we see a lot of players do that and upload their gameplay on different websites. So if you're recording your game, then the recording process might be happening on a different thread. And all of this will be happening at the same time while you're playing the game. Let's look at a different example. Let's say you're streaming audio, let's say a podcast, or you're listening to music on Spotify. So our process would be the audio streaming application. And there, the main thread probably will be in charge of managing the audio playback, while other threads might be used to do different things. For example, if you're listening to a song, that song does not reside in your system's memory. So if you are to hear the song, then it has to be read over the internet connection. So a thread might be managing that connection and reading the files over the internet, while a different thread might be decompressing those files so that you can play it back on your computer. At the same time, a fourth thread might be updating the display on your screen, which might let you know how many minutes of the song you've already heard. So you see, each application has to do a lot of things at the same time so that we can do what we want to do. If we are listening to a song by streaming it over the internet, then a lot of other things need to happen for us to be able to do that. And they need to happen at the same time. And there can be many other examples of such applications. In fact, most applications that we use today are concurrent in nature. What we will look at in this chapter is how we create threads and how we can utilize threads to accomplish different tasks. In the next video, we'll talk about threads in a bit more detail, and we'll see how we can create thread objects in Java.